look at for polynomials, just a few things. This should be pretty quick because we've already covered zeros and what zeros and solutions are. The same as your x-intercepts. Zeros, x-intercepts, solutions. Oh, and my computer's just being really sluggish right now. The points at which the function intersects the x-axis. A polynomial function of degree n can have at most n real zeros, whatever the highest degree is. An even degree polynomial has an even number of zeros. An odd degree will have an odd number of zeros. Okay? Now, they might not be exactly the same, but they will be the same, either even or odd. So, example number 1, I've already put into Desmos, graph each function and identify its zeros, so where it crosses the x-axis, like I was kind of saying in the last video. So click right here, where it crosses the x-axis. One of them is at -2, so really when you're doing x-intercepts or solutions, you only have to say what the number is in the x position. So -2 would be our lowest one. And usually you see these put in fancy brackets. Well, that was supposed to be the fancy bracket. -2. Alright, and then the next one is 0. And then the next one is 1. So 0 and 1. And just like that, that's your zeros. Okay? And in this case, it does match. You have a polynomial degree of 3, and you have 3 different zeros. Okay? That won't always be the case, but in this case it is. Okay, and then the next one, so take a look here. We have 4, so we could possibly have 4. We'll see. Alright, so I'm going to pause the video and type this into Desmos. If you want to do the same, you can. Okay, so here is number 2 graphed out. Okay, so we have 4th root, or 4th degree, not root, and so we should be looking for maybe 4 answers, right? Well, you're going to see. We only have actually 3 intercepts. So we got -1, 1, and 3. Why is that? Well, what I'm going to go over is that sometimes your 4th one is whenever you have a vertex of a like parabola type thing that hits like this. So see how this just goes straight through. If it goes straight through the dot, it's only considered one solution. But in this case, when it comes down and hits the dot, but then goes straight back up, we call that a bounce. It's going to actually bounce and create 2 solutions here at once. We only had to put it once, but this is where people can get kind of confused on polynomials. Like, what? There's only 3 answers, but it's a 4th power. Well, that's why, because it does a bounce. All right, and then this answer's at 3. So the answer solutions are -1, 1, and 3. I don't know why it's doing that. Sorry. If you're not listening to the video and you're watching, you're probably going, huh? Yeah. Alright, linear factors is a way to have polynomials reveal their zeros. Linear factors can be found by writing the polynomial in factored form. So if you wanted to, you could write it out in factored form, but, well, actually we're not going to do that. But that's, like I said, if you, like you could take out the GCF, and so this would be X, and blah, 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 and all that. That's the same thing as getting your zeros. Like, remember this, you have your sets. I'll just go ahead and put what the answers are. X minus 5 and X plus 3. Just to show you that this is the same thing as these answers that we just did. You take each factor and set it equal to 0. So x equals 0, x minus 5 equals 0, making your solution 5. And then here your x would end up being -3. So the zeros would be -3, 0, and 5. Alright, so just remember that, okay? Moving on to multiplicity. So this is kind of getting what I was saying. Let's see. So the multiplicity has to do with what I was talking about previously, that the graph will bounce. Alright, I'm going to go ahead and write out what this one factors out to. This one comes out to be x parentheses x minus 3 parentheses x minus 3. So we have a duplicate of a factor, right? So the zeros are, well, this one's solution is 0. And these each have a solution of positive 3. So these are the zeros, and what's their multiplicity? So 0, what that means is how many times do we get the answer 0? Only once. So the 0 has a multiplicity of 1. It's only used one time. And how many times? What's the multiplicity of the 3? Well, we had that twice. So its multiplicity would be 2. Okay. So hopefully that makes sense. Multiplicity is just how many of those factors have that same answer. That's all it is. Okay, then how does it affect the graph? We've kind of already mentioned this. So I went ahead and graphed this. And then we can see the zeros. So we had the solution of 0, which is right here. All right, so x equals 0 had one solution, and then x equals 3 had the 2 solutions, right? So again, this is how it connects. It goes straight through. So if the multiplicity is odd, we're going to call that where it crosses. So this is where it just simply crosses or intersects. Because I have one solution. One solution is odd, so it crosses. When my multiplicity is even, in this case, this one was even because there are 2 of them. Then the graph will bounce. Or it bounces, I guess. I need an S on there. So crosses and bounces, okay? So those are 2 terms that you've got to make sure you know what they mean. Cross and bounce. All right, so what I'm going to do is do an example of where you say what the 0 is, and then how many times it occurs, and then what it's doing there. So is it a cross or is it a bounce? So I'll do this first one. Actually, this first one's pretty easy because I don't have to graph it. Yay! All right, so this one, x plus 7 squared. That squared is super important. So here, I know what number would make this factor 0. The opposite, right? Opposite of plus 7 is negative 7. So x equals negative 7. And then I have 2 of them. So I'll just go ahead and fill it in. So I got negative 7. And then because of the x squared, I'm going to put a 2 right here. What's the effect when it's even? Well, we just went over that. When it's even, it's going to bounce at that number. It's not going to cross through it. It's going to bounce. So see, I can tell, again, a lot about my graph without even graphing it. Pretty cool, huh? All right, let me change color. Maybe make this a little easier. So 2x plus 1 equals 0. 2x plus 1 equals 0. Minus 1 to the other side. So 2x equals negative 1. Divide by 2. And x equals negative 1/2. So yes, it is possible to have a 0 that is a decimal or fraction. All right, and no exponents on this one. So that means I only have one of them. And this is because it's in the form of factor. It's already in factored form. See how number 7, you're not going to have that. You can just put it in Desmos and get them that way. But I'm showing you how you can do this from factored form because it is pretty easy to do it. And you don't even have to use Desmos. So since I have an odd number multiplicity, there's only one of those solutions of negative 1/2. That means it crosses. So it'll cross through what number? The 0. It'll cross through negative 1/2. It'll go straight through negative 1/2. On this one, it'll bounce at negative 7. It'll touch negative 7. Okay, like that. Okay, the last one. X. What value would make this a 0? So the opposite of minus 4, this would have to be a positive 4. So that's my other 0. It's positive 4. Now I have an exponent, and the exponent is my multiplicity. And since it's odd, it's going to cross. not going to bounce, it's going to cross. Okay? All right. Why don't you try number 7? You can just get that from Desmos. So you could do this a couple ways. You could just go ahead and put it in Desmos. You could also practice, if you want, you can practice your factoring skills and take out a GCF, take out x squared, and then see what you got left, break it down and get it into factored form. So you could do it either one of those ways. Just do number 7 and don't worry about number 8. And you can pause the video and try it out and then press play when you're ready. Alright, hopefully that didn't take too long. So here is the work factored out. Remember, once you take out the GCF and you have this quadratic, you can just put this quadratic in Desmos and get your solutions. So your solutions to this were -4 and +2. Or, well, 4 and -2. But anyway, 4 and -2, but remember when you make your factors, you have to take the opposite of each of them. So, or you could have just gone straight to the graph, and the graph came out looking like this, and see your solutions are -2, 0, and 4. Same thing, 0, 4, -2. So the 0 came out x squared, and so that should bounce, and it has a multiplicity of 2. So, which it did on here, it bounced, so it hit that 0 and it went right back. It doesn't matter if it comes from down to the point or up to the point. Either way, that's still a bounce. Okay, and then each of these 4, -2, it just went straight through each of those, so it just simply crossed. Okay, hopefully that doesn't seem too bad. All right, see you next time.